Or what did you, to the -1, did you say?
-4.
Shouldn't it be 4 times 10 to the
-4.
-4, yeah.
That's what I said, yeah, 4.
You wrote the right thing down, just didn't say it the right way, huh? Okay. I just realized I forgot to turn on the record, so who's ever.
Oh, boy.
So whoever's, you guys are going to have to be my my tutors now.
Nice.
I don't think that people
Okay.
want
I don't
that.
think anybody wants me to tutor them.
You know,
Well, like I've said before, is the advantage of tutoring is twofold. One, if you can't explain it, then you need to ask the teacher. And if you can't explain it, you don't need to study that anymore. So you've cut down on your study time, or you eliminated some study time, let's say it that way. Okay, so then we have that answer. We need to put it here again. And we want to end up with molar. So we're going to take our moles of HCl, and to get it into molar, we have to have liters on the bottom, but they didn't give it in liters. They gave it in milliliters. So to fix that, we did what?
Multiplied it times conversion factor.
Okay, multiplied it by the conversion factor. Either milliliters to cancel out our liters, or not, our milliliters to cancel out, so that we'll have liters, let's say it that way. So your final answer is?
.033.
That is correct.
And it'd be molarity, right?
Mm-hmm.
Yeah, big M, right. Now, one thing I want to do for you is, for those two problems, I want to show you, like it showed you, I gave you in the video, I mean the PowerPoint, I cut for the answer. So, let's see, okay, so you see this equation there? It's written over it from the lecture. Let's see, I need to slide this down so you can see the problem again. Now, there's different ways of writing this. The key, I think the key to remember on this one, I'm just going to give you the basic one that we use. And this says the volume of the base times the molarity of the base is equal to the volume of the acid times the molarity of the acid. And if they're in a 1-to-1 ratio, that's the only equation you need. But some of ours have more hydroxides or have more hydronium ions. And so to fix that, we put a number in the front. Now, I think what's in my PowerPoint is different than the formula sheet that I'm going to give you on the test. So I'm afraid to maybe eliminate that confusion. You notice that this side is the base, and that's the OHs. Notice the A is the number of OHs, So whatever letter goes here, in this PowerPoint, I have it as an A. But I think on the formula sheet that I'm going to give you for your test, it has a B there. To me, what's on the formula sheet makes a lot more sense than what this PowerPoint is. OHs are part of bases, right?
Mm-hmm.
So I'm going to put a B here so it matches what's on the formula sheet for your test. Bases have OHs. Acids have hydrogen ions. So it still works from the PowerPoint, except they have the lettering is different, not what it means. Okay, so let's go to this and let's just look at the balanced equation. We said they're in a 1-to-1 ratio, right? So this is 1 for hydroxide. There's 1 hydroxide here. What's the volume of the base in this problem? Isn't it 30.0? So 30.0 milliliters. And what's the molarity of our base? We don't know it. We're going to put MB right here. How many hydrogen ions are there per acid? 1, right? What's the volume of the acid? 20.0 milliliters. What's the molarity of the acid? And it's 0.0100 molar. Okay, so let's solve for MB. So on my calculator, I'm going to take 20 times 0.0100, divide it by 30, and that would be my answer right there. So you could do that whole problem instead of going through the steps of figuring out the moles of each and using the mole ratio. This gets you to that right away. The mole ratio is actually here. It's the A and the B. It just looks, it's been divided up. So on my calculator, if I turn it on, and I'm going to see my calculator enough. I don't want to cover up my answer, so I'm going to take 20 times 0.01 divided by 30, and that was my answer. So that's kind of a shortcut. So you can solve those problems 2 ways. This, I think, is the faster way once you understand how it works. Okay, now let's do the second one yet. Do it the shortcut method. So again, I'm going to have B for base. That's the number of OHs times the volume of the base times the molarity of the base is equal to the ions that produce the acid produces times the volume of the acid times the molarity of the acid. Okay, how many OHs are there in this one right here?
2.
Okay, there's 2. Okay, my volume of my base, 20.0 milliliters. What's my molarity of my base? Okay, my HCl, this HCl produces how many hydrogens per molecule? Isn't it just 1? And then my volume of my acid, times my molarity of my acid. So with my calculator, I'm going to take what's on the left side. I'm going to take 2 times 20 times 0.01, and I'm going to divide it by 12. And I have my answer, 0.033. So that's just a shortcut way of doing those two problems. So either method would have worked on this one. I'd count both of them the same number of points. So we good? Okay, so then we have this last thing yet to do. And I think what would be helpful to that is to go to the, let's see, where was the, they're wanting you to draw something in here that is similar to this slide, which I'm gonna have to share with you. Is that, can you see my PowerPoint or not?
Yeah, I can.
I
Okay.
can see it.
Okay, it's on my screen, but I was afraid I was just pretending to, or you were just pretending to see it, like the emperor's new clothes. So let's look at what they say. They sketch the titration curve for a 50 milliliter 0.1 molar NH3 that is titrated with 0.10 molar HCl. Now, one of them is a weak base, right? This over here is a weak base. And this one is a strong acid. But we're starting out with the weak base first. It says we're titrated with so the base is in there first. If it's weak, now if you look at the diagram on the PowerPoint, you notice that when you have a strong base, it gets up there in the 13, 14 range. Well, if this is a weak base, it's going to be lower than that, probably in the 10 to 12 range is probably where it's going to start. So somewhere in here is where we're going to start our graph. And it's a strong acid, so it's probably going to end up down over here somewhere in the 0 to 1 range. Okay, now we know it's going to start high and end low. So that's going to be sort of opposite of what, if you took this graph and flipped it around, what's on the right would become on the left, what's left would be on the right. You kind of have an idea of what might be happening. Now here is a strong base, but a weak acid one. A way of looking at this one is to flip this thing top to bottom instead. So if I'm going to put a strong acid into a weak base, will it change the pH very fast or slowly? A strong acid into a weak base, will it change the start over. Will it change the pH rapidly or slowly?
Rapidly.
So we're going to need to, this line on here is going to need to not start out so flat, but it's going to actually start going down almost immediately. Then we need to figure out where's our vertical line going to go. That's the only thing we have left. How do these concentrations compare? this is 0.10, right? This one, 0.
So it's like one.
Yeah, they're equal concentrations. So how do you, what do you think will be true of the amounts I'll need of each? Be the same. So if I started out with 50 of it in here, it will be equal amounts when we get to what? When we
40.
50.
when we're going to get to 50.
Or wait, 50.
Yeah, 50. So here's where the vertical part of my line is going to need to be, right in here. So slope it down to about 50, then drop down and then since it's a strong acid, it's going to turn pretty short and come out over here. But since it's a weak base, it's going to change really quick till it gets to 50, go down and turn really short and come out over here. That makes sense?
Yes.
So it's more of an estimate than an actual, like,
Yeah, it's kind of like an S, right? Yeah.
I was saying an estimate, not like a
Oh, estimate, you're right.
exact. Yeah.
The shape of the graph is like an S. That's what I was thinking. But it's more, yeah, you're just kind of approximating what you think will happen. And I think
Okay.
I'm surprised if we really did this, you probably wouldn't be all that far off. From just what we know how it works.
Gotcha.
So, anything else?
So for 9, is it just drawing the graph? We don't need to write anything with it, just.
I don't have anything on my answer key more than just drawing the graph. Oh, yes, there is one more.
Okay.
Well, why don't you add the equivalence point in there? So on that vertical part that you draw on your graph, somewhere in the middle, put a little dot and then just label it equivalence point. But it doesn't say that in the instructions, so if you left it off, I couldn't penalize you. Okay, so tomorrow we're going to be doing this acid-base titration. It's a simulation on the computer. It isn't very hard at all to do. The only thing that I ran in a problem with doing this simulation is when you go to, or when you click on my link, my computer immediately popped up with this puzzle piece in the screen that said that was it flash? I think the flash is blocked. And to be able to get it to work, I put the instructions in the lab tomorrow, so if you don't remember this, you can just look on the lab. But if you go to your address bar way over on the right, you'll see another little tiny puzzle piece. And if you click on that, it will allow you to change that, modify it so that it will ask you a question instead of just blocking you. It'll allow you to click on the puzzle piece and say, you know, like I want to allow me to do that this one time. So all it's doing is allowing you then to do it one time. You don't have to go up to that little tiny puzzle piece on the address bar a second time if you wanted to run the simulation in the future. You've already fixed it. You're basically modifying the settings in your browser. And then, I mean, once you do that, then I think I have the instructions. I actually followed my own instructions to do the lab to see if it would actually work. And seems to work out fine for me anyway. I hope it will for you. And then on Thursday, we have is the day that you can check your review questions. If you finish your review questions ahead of time, you can turn them in. In other words, scan them and turn them in, and I'll give you 3 more points on your test like we've done before.
So it's not due today necessarily, just before the test.
Well, I'd like it to be, but since this is all online, if you can turn it in the day before the test, yes, you know, the day that we review, we'll count it.
Okay.
Where do you want us to turn in the study guide? Do you want us to turn it in with
You
the
mean like the
section
no-
review or?
Oh, you mean okay, study guide. All right, for the test, are you talking?
Yeah. Yes.
Oh, yeah, that's the review questions I was talking about. The review packet, okay, it goes
Right. Where do you want us to turn it in?
the day before the test. So that would be Thursday.
But
But do you want
where?
us to
No,
send
like
it to you like
where?
in a chat?
But where? Do you want us to attach it with this homework?
What I did, or what some people did last time, and I think it works probably best, because it's easier for me to check it if you do that, is when you go into Teams and your class, at the top it says Files, and you can just upload it to the files there, and then when I click on it, I can view it right away. As long as you
Okay.
put it in Word or PowerPoint. But that's all I'm accepting anyway, but as long as it's not PowerPoint, I just take that back. PDF, Word or PDF, it'll, I can check it to see how you did. Yours will probably be a PDF would be my guess, because you're gonna scan it.
Mhm.
Anybody having trouble scanning it from your, just trouble scanning it? Some of you probably have scanners at home on your printers, which makes this easy. But if you don't, you can, remember, you can do the scanning with your phone.
Yeah, that's been working well for me.
Yeah, like the one I told you, I'm really partial to that Office Lens. I don't know why, I just like how it works. Maybe it works,
Yeah.
that's the way I think. Right. So yeah, put it in files. Yeah, and that way you don't have to email me, you know, as an attachment or anything like that. And that way all of yours will be in one place and not in 20 separate emails. I may need to put that in the instructions on Thursday to where to put them. I think I have, but I'm not sure. And then the other thing I mentioned was I'll actually on Thursday have it as one of your resources that you can click on. It's actually just a formula sheet that you can use for the test. It's already in files under class materials. It's already there. But you'll get to use one of those on the test. So on the test, you'll get to use your periodic table, this formula sheet that I gave you, your calculator for the test. So any questions you have still? Well,
No.
Nope.
well, we're down to 3. So it's too bad I forgot to turn on recording at the very beginning. So you got the full version. Okay, not sure what that was all about. A bunch of noise outside my house.
Maybe use a trash can. It's kind of windy, or it has been at least.
I think my wife went to go check. Well, anyway. What was that noise?
You're loading up the cement. I was going to
Oh, that's right. They removed some concrete in front of the street yesterday. Today they poured the concrete. Now they're picking up these huge pieces of concrete and dumping them into a truck. And when it hits the bottom of the truck, it makes a lot of noise. Okay, makes
That
sense.
makes sense.
Sounded awful. I thought something was happening to my house. Well, if not, then if you don't have any more questions, I guess we can sign off. It's good to see you guys again.
We'll see you
Yeah.
too.
Good to see you too.
Bye.
Bye.
Bye-bye.